Welcome Jaideep, Satish, Sarvanan. We'll wait for a few minutes for everyone to join in.
Hello.
Hello.
Good afternoon, sir.
So welcome everyone. I think it is 3:05. We'll get started. So we have Bhupender, Jaideep, Sarvanan, Satish, Smita, Preeti. Okay, so we completed till SPACY. Okay, now what we'll do is I will show you some practical examples of how these solutions are implemented and how we deploy them. That is what I will show all of you. You will get good idea. So yesterday we had Jaydeep who was asking a question: how do we run the models, where it is used, how it is. So like in one team, in a team that we generally work, there are many different uh, 1 second, there are many different skills that are required. Okay, so it is not just one skill that we are using to build a solution. Now, for example, let me just show you uh, some of the slides. So here you can see on my screen. Do you all see here? Okay. So
Yes, sir.
this is an example of streaming analytics. Okay. Do you see here?
Yeah.
Okay, so what I'm doing today is, covering, since we will be now reaching, in another 4 sessions, we will be completing all our learnings. So what we'll do is I will be showing you the roadmap. Okay, how you can learn, what are the different things that you can work on when you go to a company, what are the different skills that you will need. Okay, that is the objective. Okay. So here on my screen, and we will also implement some practical solutions. Okay, that is what I'm going to show. So this will include a combination of skills. It is not just one skill that is there that will help us implement solutions. We need multiple skills. Okay. So I'm just pasting some diagrams for you all to see uh, what will be the how do we build the different skills, what are the different areas we need to work on. That is what I'm just showing. 1 minute. Yeah, now do you see this on my screen? Is it visible?
Yeah.
Okay, so this is a diagram with regards to streaming analytics. Now you can see where does machine learning come in. Machine learning is coming here in this portion, and this is the deployment that has happened. Okay, so when we are sourcing the data will come from multiple sources. Okay, but this what you see here in this diagram is the final implementation. And the final implementation, once your model is built, you may spend about 3 to 4 months building the model. And from after 3 4 months of building the model, you may again spend another, the engineering team may end up spending at least 6 to 8 months deploying the entire model. So that is the amount of effort that goes in when you are practically taking data science to a product or to any other skill. Now look over here, the amount of different tools and technologies that are used. So you have Akka, which is a streaming tool. There is Amazon Kinesis, there is Kafka, Flume, Cassandra, all of these are different types of databases. Now we may wonder, okay, let me start working on Kafka. There are people that work on Kafka for 5 to 6 years, okay, only on Kafka, not on any other tool. They specialize in that. So it is not that we can quickly get onboarded with these skills and suddenly we'll become productive. All of these skills, they need certain amount of expertise to build a product. Okay, so what you see here is again Apache Spark, how Apache Spark is getting implemented, and you are building a stream processing unit, and finally the data is being written into various data storages. So this is about Apache Spark. Then what you have is different tools that are used to write programs on Apache Spark. So you have R, Python, Scala, Java, and then there is machine learning libraries, streaming, SQL, graphics. All these are different tools that are used when you build solutions. Now here I am just briefly touching upon Apache Spark and what are the different interfaces it works with. So on similar lines, what I plan to do is implement one solution for all of you and then show you all how these solutions interact with each other. Okay, so we are using a stack of technologies which are there from Google to do the implementation. So you will have different tools that are used in different cloud environments. So here uh, predict. Okay, so what we'll do is let me just take this and yeah. Overview of real-time analytics. Okay, I'll see if we can do something around Spark, but we will start with uh, using how do we predict visitor purchases with a classification model in a BigQuery ML model. So BigQuery is a tool. BigQuery ML model 2 ML is a tool from Google Cloud. Okay. Now, what we have all learned here so far is basics of machine learning. I'm just taking it all a little ahead, to show you all how you use these as different tools in various platforms. Okay. Any questions on what we are doing and why we are doing it? Anything you want to know? You have any questions? Okay. So what are the different things that we are going to do? We will be So we will be using BigQuery tool. We will be using a public data set. We will explore the data set. We will create a training and evaluation data set for doing batch prediction. We will create a classification model in BigQuery ML, evaluate the model and predict and rank the probability of this visitor. Now we are using something that will be like a clickstream data, and this clickstream data is being imported into a database called as BigQuery, and from within BigQuery we will be using a machine learning model. And once that prediction is done, we can imagine this is move to a SQL database, and from that SQL database, we will be able to make predictions about our visitors and send them promotion information. That is the plan. I hope this is clear, everyone. Does it make sense what we are planning to do next? Okay, you all can see on my screen.
Yes, sir.
So yeah, we are going to use a public data set of e-commerce, explore the e-commerce data set, create a training and evaluation data set, create a classification model in BigQuery, evaluate the model. So this is how we do things on the Google Cloud platform. That is what we are going to learn a little bit more today. So let me share my cloud screen. Okay. So this is the cloud platform we have. And so let us go to a big data tool called as BigQuery. So you can see on my left, I am going to this cool tool called as BigQuery here. And in this explore window, we are writing data to insights. One second, just hold on. I think I opened the wrong project. So here, let me open BigQuery. Give me 2 minutes. I'm just setting up the data set. So here you all can see what I'm trying to pull is a Google Analytics data set. Okay. So this is a large data set which I'm trying to pull into my BigQuery system. So so here you all can see what I just did was There are some setting issues which I am trying to fix. Now it should work. Searching for a public data set. Please give me 2-3 minutes. I'm just trying to set it up. Okay. So let me show you step by step what I just did. I logged into Google database, and from Google database, what I did is I opened up a public database that Google has provided. So this is a very large database. So if I go here and I type add data, so what I'm going to do is I'm exploring public data sets and external data sources. So I'm exploring a public data set, and the name of this data set is Google sample analytics data. Okay, so this is Google Analytics sample data, and this sample data is Google's data from 2016 to 17, and it has an e-commerce data. And this e-commerce data we have pulled into this data set called as BigQuery. Okay, now if we have to explore this data set, what we can do is we can go here and we can see there is data about 2017 and 16. This is the table schema. Okay, it has information about visited ID, visitor number, visitor visit ID, visitor date. So this is all clickstream data. And this clickstream data, if we want to view it, okay, what we can do is we can go into preview. We can see here, and in the preview section I can view this data. So here, since we ran this query, it is only fetching data for that query. So I'll just delete this. Okay, and when I'm clicking on this query, it is showing me a results of data. So it has a lot of information. So this is so I'm going to the first page, and this should show me a list of data of all the users who are trying to visit this website. So it has tons of information that is there with regards to who is visiting our website. You all are with me? You know what we are trying to do is get a very large data source and then use a tool to make the prediction. So a different way of doing predictions. So now the first step, what we are going to do is, we will run some queries, and using these queries, we will try to explore our data. So one of the first query that we are going to run on this data is okay. So what we are doing here is we are trying to count the number of unique visitors who have visited this website. So we want to find the number of unique visitors, the number of purchasers, and then finally we are going to total the number of visitors who are the purchasers and what is the conversion rate for our website. So I'm just running this query here. You see, what it is showing is there are total 74,170 741,721 visitors. The total number of purchasers are 20,115, and the conversion rate, that is people who come to our website and then make purchases, the conversion rate is around 2.69%. Okay. So this will be 0.0269. So approximately if you divide it by multiply it by 100, it will become a conversion rate of 2.69. Now, a few exploratory data analysis which we are doing on this data set. So the next exploratory data analysis we are doing is we are trying to find which products are sold and what is the revenue on that product. So we are trying to find out which are the most sold products and what is the revenue that we are earning on those products. So here we are running one more query. And this query is giving us which are the products that are being purchased, what is the category, how many units were sold, and what is the revenue that we got. So we are trying to figure out which is the most sold products and what is the revenue that we are getting on these products. Now the next question we want to find out is, once the user comes to our website, okay, what is the when the user comes to our website first time, what is the number of repeat customers? Okay, we want to find the number of repeat customers who are coming to our website. So we are running another query here. In this, visitors who brought a product on a return visit, they could have brought it on the first visit also, but what we are trying to do is how many return visitors visited our website, and what were in their second visit, they also made a purchase. So total number of unique visitors are 741. The transactions we have here. Now from here, we are counting the distinct visitor divided by the total visitor, and these are the visitors who purchased on return visit. So they could have brought on the first visit also, but here we are trying to find what is the purchases they are making on the return visit. So just run this query. So here we have total visitors, and these visitors did not buy on their first visit, but around 11,000 visitors visited the website again, and then they made their purchase on the second visit also. So this is, we are finding insights on the data using SQL query. So running SQL queries is a great way of finding insights in your data. So this is also a kind of exploratory data analysis that we are doing. So what we are doing is we are going to generate the data set for our project. So in our project, what we need to find out is we want to predict visitor purchase, which visitor will purchase using a classification model. So we have to generate the data set. So we explored our data set. We are now going to create a training and evaluation data set for the prediction. So here we are running another query. Now what this query will contain, we are trying to find who are our who are our visitors, okay, who came to our website, what is the visited ID, the total number of bounces. Total number of bounces means he visited our website but dropped off, that is the total number of bounce. How much time he or she spent on our website, then what are the total visits that are made to our website. So we want to have users who have visited our website at least once, and then we are doing a join on visitors who have transactions on our website. Okay, so what we want to do is we want to find which visitor will come to our website and make a purchase. So we are generating the training data for that. So what we have is the total number of visitors in this row. The number of bounces means he came to our website and bounced off. That means didn't stay on our website. How much time that person stayed on our website, and did he make a purchase on his return visit. So the user may have made a purchase on the first visit, but we are also trying to build a model that will predict if this user is making a purchase on a return visit. So I'll pause here, friends. I've been trying to do a lot of things, but I hope you all are getting an idea what we are trying to do. Can you all type a yes or say yes on the chat?
Yes, you are using Cassandra data to generate a data set. So,
Correct. We are using a Google BigQuery. Actually, the name of that database is called as BigQuery. And a lot of this data, when you go to companies, they will be in a database stored, or they may be in CSV file, and we are trying to use that CSV file to build a model. Does that make sense, everyone? I think Jaydeep has answered. What about the rest? Is it clear what direction we are going in today? This is something very different that we have done so far, because most of the time what will happen is we are only getting the data and we are working, but this time we are trying to generate the data from the source data set. Is it clear, everyone? Okay, I'll be sharing these queries and examples with all of you so that you know how queries are written, SQL queries are written. Learning SQL query will add a lot of value to all of your skills if you join any company as a data scientist. Okay, so that is why this. Is this helpful? Otherwise, I can take up another example also for you. You all feel value in this, what we are doing?
yeah,
Okay.
I don't know about others.
I'm just hoping, my aim is to kind of show you all some practical stuff beyond machine learning, how it is done. So feel free and tell me if you have any doubts. Okay. So we created a query from the data set. Now our next task is we need to create a data set, okay, called as e-commerce. It will be our database, and we have to load our data set into that. So what I'm doing here is, on my right, you can see I'm going to click here and say create data set, and I'm calling this data set as an e-commerce data set. So I'm clicking here on create data set. I'm just clicked on create data set here. It created a e-commerce data set. So if I go here, I have e-commerce data set. So in this e-commerce database, we will run a query. Okay, so let me just run this query.
This e-commerce database you created using that public data.
Yeah, I still did not create. I just created a blank data set. In BigQuery, you call it as a data set. And what I'm doing is I'm actually loading that data set with the data which is there in the public. So you can see this is the public data set.
How do you get the name from?
So the name is here. The moment if I go here, the moment I loaded the data set, you saw earlier when we load the data set here, when I clicked on open, okay, or when I clicked on add data. So in this add data, I went to the marketplace, and from the marketplace, I loaded a public data set. And when I loaded the public data set, this was the public data set. So once it gets loaded, so this is the BigQuery public data set. And here you will see a data set by this name, e-commerce. Okay, so if you go into here, e-commerce, so when we went here and clicked on add data set, okay, it loaded as a public data, and this data was known as analytics and GS sessions. Okay, this is what it loaded. And internally, this data set, okay, when it is getting created, uh, it is creating it under name of data to insights e-commerce dot web analytics. That is how it is getting created. And where we found that information, if you go here, data to insights. So what Google does is, since it is a public data set, it is not loading that data set on our project. That is what it is doing. So if I just click here, and if I say public data sets, okay, and from here, when I type Google sample, okay, when I type Google Analytics sample, and I click on this Google Analytics sample, it is a data set that Google is making us available over the Google Cloud. He is not adding it within our system, but he is making that data available for us. Make sense? Because it is a very large data set, we could end up paying for it. So when I click here, you can see it has loaded the data. Do you see here? Okay, when I
Yeah.
click on preview, okay, when I click on preview, it will show me that data set. It is still loading. Okay, so it has showed me that data set. If I click on query, it will preload that data for me. You can see here, the moment I clicked on query, it is showing me the path where it has stored the information. So it is not on our project, but it is showing us the path. Do you see here? It is saying BigQuery, public data, Google Analytics sample, GIS sessions. This is where it has stored. So if I remove this, and details, schema. So this is BigQuery, Google Analytics GIS session. So BigQuery, public data, Google Analytics. Okay, this is Google Analytics GIS sessions. Now, when we ran this query, what it did is we, in this particular query that we just ran, so in this query that we just ran, what we are doing is we created a data set called as e-commerce already. And in that e-commerce, we are creating a table called as a model called as classification model. Okay, so this is the model. It is not a table, it is a model. And the model type we are using is logistic regression. And the label that we want to use for prediction is called as will buy on a return visit. So this is the model building which we are doing in BigQuery. And then what we are doing, we want to load the data. So we are saying load everything except full visitor ID. So this is the data which we are loading. And what we want to load, we want to load full visitor ID. These are the features. We are loading the number of bounces. We are loading the number of time that person spent on the website. Okay, and we are loading it from a data set called as data to insights, e-commerce, web analytics. Okay, and we want to load data where the new visitor has at least one visit, and the date time that we have is between 2016 to 2017. That is the first 9 months. And then we are again doing a join to the visitor ID on the visitor ID, in which we are counting the number of transactions. So we want the user to have made at least one purchase on the website. That is why the total transaction should be greater than 0. Total visits is null, which means the user has so what we have here is the total number of transactions he has done on the website should be greater than 1, and new visits is null. He has not made any new visits. So if we count these two values, that is transaction and total new visits is none, it should be greater than 0. So if it is greater than 0, then put a value 1. If it is less than 0, it should be a value 0. So, and we are saying that will buy on return visit. So that is the data set we are getting created here. So if we run this data set, it is giving us a result here. Let me just do control and process this data. So the result is, it is creating a new model. So if we go to the model, it is showing us the model that it created. Okay. Now, if we have to evaluate the model, what we'll do is we will see the ROC curve and the AUC curve that this model has created. So if we click on query the model, okay, so it automatically shows us what kind of model it will create. So what we are doing is we want to find the ROC curve of the model. Okay, this is the evaluation of the model. It is there in e-commerce classification. This is the data set which we are giving, and then we are saying do a join on full visitors who have visited our website. So if we run this, so what we can see is it is telling us that the model that got generated is giving a ROC AUC curve of 0.73. Now, how do we improve the model? Okay, so what we'll do is we will create another package. So we are just creating another package. Now in this, we are creating e-commerce classification model 2. Okay. And in this, we are passing model type logistic regression. Label is will buy on return visit with as visitor stats. And then we are passing full visited ID, the total transaction, and total new visits is null. So if you have total transaction greater than 0 and the new visits are null, then the value should be 1, or if there are no transactions and no new visits, then the value should be 0. So this will be will buy on return visit, and we are getting it from the data to insights e-commerce web analytics uh, data set. And here we are adding more information to the data. So what we are doing is we are saying select star accept unique session from we are creating a new data set concatenating the full visited ID and visit ID. This is the unique session ID. Will make a purchase on return visit. Then what e-commerce actions they are taking, what is the behavior on the site, how many times that user has bounced, that means how many times the user has gone away from the site, what is the time the user has spent on the website, how many page views he has made, where the visitor came from, what was the source, the traffic source, medium, channel grouping, device category, okay, the network, which country he is from, and then number of hits. So all this information is now being loaded into the data set. So if you run this,
What does this unnest function does?
one second. Unnest. So it is fetching from this BigQuery.
I believe hits is the table, I guess, right?
Yeah, hits is a table. So what unnest will do, so it takes a array as a input and returns a table of that array.
Okay, okay.
So
okay.
Here unnest operator. So unnest is taking an array expression and returning a table.
Okay, okay. So it's converting an array into table and then.
Yes. So
Okay.
unnest operator takes an array and returns a table with one row for each element in the array.
Okay.
So here the hits is being hits is there as a column. Let us see. So it is hits is a column and it has a list of, it is a record, and within the record there is a nested column that is there. So you can, so we have this is the visited. So this is like a JSON data that it has stored, and this in this JSON data it is stored like an array. So you have a record total, and within that you have visit, hits, page views, time, okay, all this information. Again, for traffic source, it is stored as a JSON file. So this it is like a nested data that is being stored. So this is basically a JSON data format. Okay, the data is tick stream, and it is a JSON data format. And within that hits, it is storing the JSON data format. So that is why it is storing as H. And since it will return an array, it is each row will be stored as an array.
Got it. Okay, sure.
Okay. Now, BigQuery has its own language called as BQL. You know, it is a sophisticated data warehouse, you can call it.
But it's kind of looking like a SQL query itself. So
Yes, it is a SQL query. The only difference between BigQuery and all other databases, Oracle can store up to terabytes of data. BigQuery can store petabytes of data. So that is a huge thing. So terabytes, 1 terabyte is 1000 terabytes is 1 petabyte. So BigQuery is able to store petabytes, whereas Oracle, SQL Server, all of these databases can store gigabytes and terabytes. Most of the time only gigabytes, but this you can see it is storing data more than 100,000 times more than other databases. So they have this data warehouse that is scalable with machine learning built into the database. Now that is a huge achievement.
got it. Got it. Thank you.
Yeah. So here, so what we did is we now, I'll just refresh this once again. We now created two models. One is the classification model 1, and another one we created another model, classification model 2, in which we added more data. Okay. Now in classification model 2, if we query, we'll query this model. Just it is, since the data is very large, it is taking a long time. So I'll just wait for a few minutes. So you can see here it has already, it is showing the ROC value. Now this time the ROC value is 0.92. Okay, we will query and find out also. Yeah, now what we'll try to do is we are finding the ROC AUC curve. Okay, we are evaluating the e-commerce classification model 2. Okay, and then we are after loading the data, we are trying to find what is the ROC AUC curve for classification model 2. This is what we are doing. So if you run this, so now this time you can see on my screen, the ROC AUC curve has increased. It is 0.09, 0.90%. Okay, earlier it was 70%. Now it has come to 0.90% because we have fed in more training data to the model. That is why. Now, if we have to make the predictions, okay, so now we have to make the predictions using the classification model 2. So what we are doing is we are saying ML prediction take the model 2 and we are passing the visitor information. Okay, we have the visitor information. How many times he visited, what is the e-commerce action he has made on the website.
It's
Traffic.
automatically trying to identify the model needed for this use case, isn't it?
We gave, here when we were creating the model, we told that it has to use the logistic model. So just like we have different models, for BigQuery also offers different types of model. You can see on my screen, BigQuery model types. Okay, so you can see here the different model types that are there. So you can see on my left, there is regression and classification model, clustering, dimension reduction, collaborative filtering, time series. So, what they have done is they have built the model inside the database itself. Makes sense?
Yeah, understood.
Yeah. So that is the power. And let me tell you, using your skills of machine learning, you can do a better job on the database now. Somebody else who is only a pure DBA will not be able to understand what to do with this. Make sense?
Yeah.
So that is the potential of building a career, which I wanted to show all of you, that there are opportunities. The thing is, AI ML is getting embedded into the applications. It will get embedded into Excel. It will get embedded into databases. It will get embedded into a RPA system. So the skills that you learn will get applied everywhere now.
So when you are doing create model, could we go back to that?
Yeah, when we did a create model, I'll just give you the query of that create model. Give me a minute. Just give me 2 minutes. Let me just run this, and then I will shut down the system. Otherwise, I will give you all the queries that we are running. So what we'll do is now, since the model got created, let us now make some predictions. Okay, that is what we will do. So here, okay, in this, what we are trying to do is we are using the classification model 2, and into that model, we are feeding the information about the users, okay, and then make a prediction. So if we run this, we will get a list of predictions. Okay, so what it is showing here in this result is, whether the person will buy on return visit probability label. So this is the predicted probability value. This is the predicted score that we have. This is the unique session ID. Will the person buy on return visit? Okay. So that was 0. E-commerce progression. How much time he bounced from the website, time he spent on the website, what was the page views, okay, where that user came from, what was the referral, okay, all this information. Using this information, now the model is predicting whether the user will purchase on a return visit or not. So this is what this model did, and we built this model from within a database. That is the most interesting part. Okay, now let me show you a document where I have listed all of these queries. 1 minute. Okay, here on my screen, this is the document of the queries that we have run, and we will see the model building query. 1 minute. Now you can see here on my screen, you can either create a linear regression model or a classification model. You can even use TensorFlow. And here is where we are creating the model. Do you see here? In the query, we are writing model type. Do you see? This is the model type. We are giving it a name.
Okay.
Logistic regression.
And the labels are like a list of strings.
The label is the dependent variable we have. So when we are creating within the database, we are creating an e-commerce classification model. We are saying the model type it should use is logistic. So here you can write logistic regression, decision tree, different types of models. And what is the label? Label means what is the predicted target value that you want. Okay, that is the target value. And after that, you are doing a select, and here you are passing the features. You see, we are passing the features into the model. So the features are visited ID, number of bounds, time spent on the website, from what period to what period. All this information is the features that we are feeding in. Make sense?
Yeah, yeah.
So first time when we built the model of classification, we used logistic. This was the predicted value, and we were passing only 1, 2, 3 features. The next time when we built the model, we changed it and we are passing more features. So you can see the first time we got only 0.272 as our RSE, and the second time we added more features. So we changed the now here it is model type is still logistic regression, but you can see here the second time the number of features that we added are more. Do you see? First time we added only 2 features, but second time we are adding more features.
Yeah.
So this is an example of machine learning model within a database, which you will start seeing coming up in lot of projects. A lot of job opportunities will come around this area also. Project opportunities will come, because you don't want to use Python and all of that and then keep doing the deployment. Here the model will start running from within the database. The data comes in and this model will get executed and keep pumping the predicted data into the database. That is how it will work. I'll pause here. Any one of you has any questions, you can ask me. Is it clear? You all found this helpful? Was it simple and easy to understand? Can I see a yes from all of you? If you have doubts, you can ask me.
Yeah, it's clear.
Okay, I'll pause for 2-3 minutes. You all can observe what we did, and any question you have, you tell. Otherwise, then we will move to the next example. I'll share this document with all of you. You can go on to Google Cloud and execute it or use it as a reference how companies are building machine learning models within a database. So one more example I'll do now. This time, how do we use the natural language uh, uh, features of Google Cloud? Okay, so that I'll just set up that. Give me a minute. The next example we'll do is how Google Cloud allows you to use the natural language on Google Cloud. 1 minute. I'm just setting it up. So the next example which we are going to use is how to, okay, so this is, so what we just did was predicting purchase in predict visitor purchases with a classification model in BQL, in Google BQL. So what it means is Google BigQuery machine learning. So the next one which we'll do is using Google using NLP natural language APIs in Google Cloud. Okay, this is the second one which we are doing. So what we'll do is first in Google Cloud, you can see on my right. Can you all see my screen? Okay, what we just did is we have predicted a visitor using Google Cloud BigQuery. Second one now we are going to use is using natural language processing in Google Cloud to predict entities. So here in this we go to the natural. First step is we will access the Cloud Shell. Okay, the Cloud Shell is kind of a command line interface for accessing the various tools on Google Cloud. So you all will have to get familiar with this command line interface. Okay, and so this is the project ID we have. You can see on my screen. This is the command line interface that is used to access Google Cloud. So it is good to have some knowledge on Linux. Okay, so this command line interface uses all Linux commands. So what we are doing is first we want to see what is the project ID. So we are saying export Google Cloud project. Okay, we are saying get Google Cloud config get value core project. So we are taking this value and assigning it to the project. Okay, so here now if I say echo Google underscore cloud underscore project, I will get the project ID. Now
You need to put a dollar before.
dollar, yeah. Yeah, so we got the project ID. Now what we are doing, we are actually setting the project ID. Now you can see this project ID labs and this project ID is the same. Okay, so we are just using that project ID. Now the next step for us is to create something that is known as a service account. Now what is a service account? Now every cloud will have a user account. So if you go into IAM here, under IAM you have user accounts. You can create user accounts and you can create service accounts. So this is IAM is used for creating service accounts. And here if you go below, you can see there is service account. So what is service account? Service account is meant for user machine to machine communication. So when two services or two machines have to communicate with each other, you should not give your user account to that machine. You should allow that machine to have its own user account. That the machine user account is called as a service account. Yes, I'll just clear this. So the next step for us is to create a service account. Okay, so we are going to Google Cloud IAM, create my natural language service account. We are authorizing it. And then once the service account is created, now this service account will need a password. Okay, so machine to machine communications, you don't want to use a password, rather you want to use a encryption key. So instead of using a password, we are going to use a encryption key. So here what we are doing, we are saying Google Cloud IAM service accounts, create a encryption key. The encryption key is in this JSON file. Okay, and it is being used for the IAM account, my natural language essay. You can see here, this was the service account we just created. You can see here, it is the name of the service account. And to that service account, we are assigning a encryption key. So if I type here ls, you can see an encryption key got created. If I do vi key JSON, so this is the encryption key. So there is private key and public key. These are actually used for security between machine to machine communication. Now, what we'll do is we will store this encryption key, that is the key.json, in a variable called as Google Cloud application credentials. Now here in this account, we need to create a virtual machine. A virtual machine is like a server that you want to create on the cloud. So here when we click on the virtual machines, there is a virtual machine that is there. Okay, so this is a virtual machine that has been created. So we will access this virtual machine through the SSH. So we are accessing the virtual machine through the SSH. Now that we created a virtual machine here, we will try to use the API of Google Cloud to find some values of our so here what we have done is we have said use Google Cloud. We are invoking the machine learning libraries of Google Cloud. And within machine learning, we are saying use languages. And here we are saying analyze the entities. Okay, and the content we want to analyze is Michelangelo Carvio, Italian painter, is known for the calling of the Saint Matthew. Okay, and then it will identify the entities and return a JSON file. So we'll just run that. So here it has written the JSON file. We can view the result of the JSON file. So what it did, it returned us entities. The content is Michelangelo Carvio. The type is proper. It is saying that he is a painter. The metadata it has picked up from the Wikipedia for this person Carvio. Then name is Michelangelo Carvio. Type is person. In Italian. Okay. So these are all information. It is also telling us that Italian is a location, geographic location. Calling of the saint. Okay, it is a proper noun, and then there is a link to Wikipedia. That is the calling of the saint, or the calling of the Saint Matthew. And so in this way, it has written as a JSON file which we can use in our programs. So this same example can be used by I think one of the things that Jaideep had asked, how do I label my documents? So this is one way in which you can do labeling of your documents. You send the data to the Google API, it will return you a list of labels. Make sense?
Yeah. I have a question regarding that SPACY implementation we did yesterday. Just going off the track.
Yeah.
In the SPACY, we were telling it to search for some keywords. We gave it a pattern and it was searching based on that.
Correct.
Is it also taking care of the stemming part also in that? Like if I say, let's say run. So will it take care of the running and everything in that same implementation?
Yeah, it was taking care. No, I'll show you that code. We will just complete this and then we can go to that code. I can show you. So SPACY was doing everything that NLTK was doing for us.
Okay.
Yeah, it was doing that piece of work for us. So give me 5 minutes. I'll just complete this and then we can go to SPACY after the break. And again, we will do one more example. So this was an example of using APIs for using Google APIs for your machine learning. Now, as you saw, unless you know machine learning basics, unless you know what entity is, what NER is, using these products will also become difficult. So the idea of showing you this is that you have all covered your basics, but you can always go ahead and explore new tools and technologies to implement it. Makes sense, everyone? Is this clear? Any doubt on what we just used as a solution? Okay. So we just escape Rolex.
These are all paid services, right? We cannot explore it without getting a license. So
Google Cloud gives you a free version which you can use. It gives you a free version.
Okay.
You can explore. So some of these features which are there, the API features, they are available for you for a limited amount of transactions. You can always use it for a limited amount of transactions. For POCs and testing, all of this you can use it. Okay, what I'll do is I will just we will go to the example of SPACY that we did, and then we will come back. So let me just open up Anaconda. Give me 2-3 minutes. I'm just opening the SPACY examples that we did. Give me 1 minute. So this was the SPACY example we implemented yesterday. So the SPACY will do all the things that NLTK did and maybe much more than that. So here we imported one of the packages of SPACY. And here we were passing the NLP object, okay, called as he went to play, and it was the data is being stored as an object, the SPACY object in document. And then we are now looking at the different types of pipelines or name components that we can generate. So you have tagger, parser, NER. So what you saw here is a tagger. Okay, so this is so what you want to see is how SPACY does the
stemming.
Stemming, yeah. So what we can do is SPACY stemming.
If we just change pass in the parameters in the patterns, if we just pass in something like playing, so it should match the play.
This one.
Yeah, let's say we pass in the parameters, we say playing, and there we keep it play. So
here you can see this one, right? We are creating a text that is there. This is the text, correct? Here, what you need to do is we need to create the students are playing.
If we change water to watering.
Okay, so this is document 1. Okay, and people, okay, let's do it above only. So here,
if we just
watering,
will
then it should get us the match.
Yeah.
So let me just comment this and put a more meaningful sentence. Maybe that is why I did not get it. Some people start their day with running. Okay. And what we want to find is with running, with run.
Yeah.
And it should give us a match. Let's see.
I guess the model that we have loaded up, it's not using the stemming or the, what was the other method? Forgetting the word.
Limmatization.
Yeah. This is not loading those pipelines.
1 minute. So So here we have to add the limitizer, pipeline component for limitizer. So here we say add pipeline. So this will be active pipelines are here. NLP.
I guess, yeah, over there. Yeah,
NLP
dot add pipeline.
Dot add
Yeah,
pipe.
And maybe just limitizer, rest can be default.
Let me see here. Limitizer.
I think the version of SPACY is a mismatch. This is limitizer pipeline is in, it says it's in 3.
V.31. So SPACY import
What version are we on right now?
it will generally, when you say import SPACY, it will get us the latest version only. So it is 2.2, an old version. Okay, so we need an updated version. So when you put a hyphen, it is going to install the latest SPACY. So when you want to write command line syntax, so in Colab you use a hyphen and install the command line syntaxes. Okay, so it is installing SPACY for us. So it has installed now the latest version. Now let us run import SPACY. So
You will have to run the SPACY download command with the with that
below.
If you go to the tutorial where you picked up the, so there is a SPACY download command.
Here, SPACY setup, SPACY pip.
There's over here, Python, SPACY, this.
So I think these all should go in together.
I think the last line has a web SM.
Yeah. So-
I think the main problem is that the collab is in a virtual environment and there is a U flag. I guess you just need to run pip install without the U flag.
Pip install without the
U flag. If you scroll.
Oh, okay. So it is taking a root user. Okay.
Yeah.
This also.
This is fine. This is
Fine.
this will run fine. It's still saying it's running as root, which it shouldn't be. It's a percentage sign, not the exclamation mark. It's
Okay.
saying, yeah, percentage. It will run within the environment.
So the SPACY is set up in this part, and
It's saying the warning message has a recommendation board.
it is recommended. It is recommended to use a virtual environment instead of pip IO. So we need to use a collab VM. So we create a virtual environment. So this is Theano. Activate. So there is a good tutorial on Collab on lemmatization. You can see here. Jaydeep.
Yeah.
Yeah. So here they have implemented what you had in mind. It is loading the encore, and then this is the text, and then it is printing the token lemmatization, all of this. So if we run this, So I'm sure there is an example of match within this. Let us see. So you can see here the text. Okay, let's run this now. So you have rain, raining, okay, verb, and then it will create a lematizer text. You can see here, rain now is being identified as rain as a lematizer, okay?
Yeah.
Okay. Now, if we want to do a match, okay, we can take the same text and implement the match here. It didn't find. Now let me just change this text. We will say it is raining in Spain and the rain falls mainly on the plains. Grammatically also it has to be correct. We are just trying to fix it. Let's see. No. It is not fetching in this case. So we'll have to see why it is not doing it. Jaideep.
I think in the old approach, it has to be passed as a callback to the pipeline.
It has to be passed as a, sorry?
Callback. So the old pipe lets you create a callback function.
Fallback.
Yeah. Callback.
Callback.
C,
okay.
C,
Okay.
yeah. So a custom callback has to be written to create the lematizer.
Okay. So, but if you see, it is the earlier example which we saw, it was actually lemmatizing it. You can see here. So it is printing out the lematizer. Now,
But I don't see that being used. I'm confused.
so here you see, we are all out in the zoo. I did some acting. I fell. Okay. Then for send start.
It's using this synthesizer function to just break it down into sentences.
Yeah. Acquiring text is here. Chunk text is here.
But the prediction thingy is match function call seems to be missing. I can't find it.
Now you can see here, we are using a more advanced limitizer. So WordNet is a more advanced limitizer. Okay, so here we have installed WordNet. Now, if we use WordNet, it may give us a result. So let me just see down. So let's see this. We install, let me run all of them, run all. So we are installing NLTK WordNet, and we are using WordNet in the SPACY. So we are using WordNet SPACY. Scatter text. So here they have a match explorer. You can see on my screen.
Yeah.
Now the model they are using SVM text to check the pattern of match. How do we use this?
So I installed the latest SPACY on my laptop, other laptop. And by default, that model that you're loading already has lematizer pipeline included. But still, when I set water as pattern, it doesn't match watering.
Can you show me on your screen?
It's a little difficult. Let me try.
Okay.
Yeah.
Yeah. So can you see on my screen here? They have implement. Jaydeep, you can see here.
Yeah, yeah.
Okay, see, this is the text that we have. And in this text, they have used N-core, and it is showing us we have used a lematizer match. Okay, this is what we are trying to match. So if I search, it helps me get match, matches, match, matches, all of that. Makes sense? Now, let me just add. So you can see here, there is match books, okay? And this is matching text, okay? So if I do a search now, matching text is not matched, but it is able to match, matches, matches, again matches, match books it is not able to match. This is matching test. Okay, so let us add few variations of match. Okay, so here I've added few more text. We are trying to find the lematizer match. It is a noun. So let us run it again. Do you see here? Match, matches, match, matches, matches. You need to play your matches very well. So it is a lematizer. The parts of speech is a noun. So if you keep adding more attributes to it, to this match word, then it is able to figure out. So you can see here, the pattern is lematizer match. Parts of speech is noun. What we can say is tag. What kind of a tag it should be? So so this is how you can see here. This is the kind of tooling it is showing, that a match is a tool. Okay, so it is building the attribute for us. So we need to give the appropriate tagging information also. Then that is how it will be able to fetch that value which we just saw here.
I was just exploring the matching. I guess it needs the lematizer match flag along with the run to match running.
Yeah, it needs the it needs you need to append it with a match. Okay, the lemmatizer is match, and then the part of speech is it is a noun, and then if you add few more attributes, now for example, if we want to find,
could we paste our text in there, and let's use that as an example. I guess we can paste our text.
yeah, we can paste here. Some people the boy is running downhill. He is a good runner. He runs for 5 kilometers daily. Okay. So what we need is a lematizer run, correct? And what is the part of speech? It is a verb, isn't it? Now,
maybe we delete the position also. Yep, seems like it's working.
yeah. So runner it did not get, but since it is a verb, it is getting running and runs. So if you add another attribute of parts of speech, so it has already taken the parts of speech, so it will not take that. So it has correctly identified running and run because both of them are verbs. Runner is like a noun, so it will not fetch that. Correct?
Yeah.
So needs more exploration. I have also not used SPACY extensively, but I have used BERT, which is similar to SPACY. Each one of them we'll have to explore and then do it. Any questions anyone has? Satish, Sarvanan, Jaydeep, Bharat, any question? If there are no questions, then we will take a 25-minute break and then we will continue. I will show you some more deployment examples using Google Cloud. So I'll just put on the stopwatch.
Sure, sir.
Welcome back, everyone.
Hi, sir.
So I will show you an example of product recommendation using Cloud SQL and Apache Spark. Okay, so that is the next one. Again, a cloud related. How do we build a cloud recommendation using cloud cloud SQL and Spark. Just opening the Excel sheet, 1 minute. So the next example we will do is three. Just give me a minute. I'm setting up the Google Cloud. set up. 1 minute. So what we want to do is we want to predict the flight arrival time or departure time Okay, we want to predict the weather predict if there is a delay in the flight. Okay, so this is what we want to do. And in this example, what we are doing is we are going to use a tool called as Apache Spark, which we already saw, to make the prediction. So this is what we are going to use. So let me just open up that file. So here in this example, what we'll learn is how to deploy machine learning models using Apache Spark. So you can do a search on real-time ML models on Apache Spark. So you will see a lot of these use cases are being used by companies like Uber, okay, a lot of banking companies, okay. All of these are, you can see here on my screen, they are collecting data. The data is streaming, passing through Apache Spark, and the machine learning model is working on Apache Spark. So this is what we are trying to do in a small way. Building up this entire pipeline will take a lot of skills, but the idea is to see how streaming data sets are implemented using Apache Spark. So there are many implementations that are there with regards to Apache Spark. Okay, makes sense, everyone? Where we are headed for the next topic. You think it is useful for all of you? Yeah. Jaydeep, Sarvan, and Satish. You all are with me?
Yes, sir.
Okay. So I don't hear anything from Jaydeep and Sarvanan, but we will proceed. So let us, the first step for us is to, what we will be doing in this exercise is we will be getting the air transport data. We will prepare an Apache Spark cluster on Google Cloud. We will create the training data set for Spark, and then we will build the model, and then we will deploy the model using Apache Spark. That is the goal that we have. So let me just put these things in the chat. 1 second. The Excel sheet. Okay, so what we are going to do is prepare a Spark interactive shell on Google Cloud, create a training set for machine learning, develop logistic regression model using Spark, evaluate, how the model is working on Spark. So this is what we are going to do, and to make predictions of flight arrivals and departures. So we want to predict if there can be a delay in flight arrival and departures. This is what we are trying to do.
Hi.
Hi.
Sorry for the delay. I found the issue. So running matches with run, but watering is not matching with water.
Yeah. Why was it?
I don't know. It's somehow doesn't direct it uh, as a stem for water.
So if you see, we used that same example for match, matched, and matches, correct?
Yeah.
Yeah. So what happens is, water is the name of the product, or running is the water is a noun. Okay. But watering is like a verb. Makes sense?
Yeah. Yeah.
So when we are annotating, then you need to add these annotations to the stem also. That is when it will work. Like for example, when we were looking up on the example of match, matched, matches. So we were able to get values for match and matches because they were nouns.
Yeah. Yeah. You're right.
But we were not getting it for matched. So whenever we are building for such kind of words, you will have to add the appropriate parts of speech to it. So when we add the appropriate parts of speech, that is when it will go and fetch those words for us.
Yeah. I was just thinking. So in a use case where let's say we get some matches from this, then somebody has to manually moderate the matches and say that okay, the matching was right or wrong. Because uh, because it's not maintaining the contextual. So LSTM, like when we were studying it, it's maintain the context of the sentence of the paragraph.
Yes.
So this is more like a keyword match.
Correct.
So Does it provide, like, I think it has more models which we can use. Probably LSTM will be one of the models.
So, along with SPACY, you will have to implement the LSTM. That is how. So if I just show you on my screen, you can see, you will generally find along with SPACY and all of this, with this natural language processing, NLP deep learning. Okay. So along with this natural language processing like SPACY, you will have to implement a deep learning algorithm with it.
Yep.
Okay. So NLP, SPACY, deep learning, LSTM, deep learning. So LSTM will do the job of the context, whereas whereas SPACY will do the stemming, all of those kind of work will be done by SPACY. So if you see here,
so SPACY is like a preprocessor to the
yes,
model.
correct. SPACY is like a preprocessor
Yes,
to
yeah.
the model.
It's not like an end-to-end solution for.
If you see our first example of NLTK, you remember where we used NLTK along with logistic regression.
Yeah.
Okay, that is the approach we will have to take for any of these NLP models. So it will work in combination. Now here in this example, you can see on my screen.
Yes.
Okay. So here, now this is an old SPACY, but they have integrated SPACY with LSTM sentiment analysis to model into the SPACY pipeline.
Yeah,
okay.
Makes sense. Yeah.
So in this case, this is the NLP and the text. We are creating the NLP pipelines with the text and the batch sizes. Okay. And once the pipeline is created, the document values are iterated through the pipelines. The document sentiment is generated. So what we are doing is we are counting the entity sentiments which are there within the NLP, using the NLP, that is the SPACY, and then using the text. So after that, sentiments are counted, then we are loading the LSTM and then creating the NLP pipeline. So here the tagging and all of that happens. It is generating the pipeline. Now within this pipeline, we will implement the LSTM. So there the sentiment analyzer is being used. Okay. So training with KERAS using LSTM. So here we have got our data from SPACY NLP. We are getting the embeddings, passing the NLP vocabulary, and you can see here when you are compiling, we are passing the embeddings that got created by SPACY. So you can see here, this is the embeddings, and that embeddings got created by the NLP vocabulary. You are passing the embedding, the LSTM and the LSTM settings. So here you are doing the model fit using LSTM on the SPACY pipeline or the SPACY embeddings. So they will work in combination then.
Yep. Understood. So like in our use cases where we were just importing from Keras, downloading data, we will be using SPACY to generate the initial load.
Correct. Because our earlier examples, when we were using LSTM or even ANN, we were actually using simple word embeddings, right? word to vector vec and all of that to split our data and separate it.
Yeah.
But when you use SPACY, it is giving you much more flexibility in terms of parts of speech, lematizer, tagger, so many information you are passing to the model, and that is how it is finding that information.
SPACY in general is an open source library, right?
Yeah, SPACY is an open source library. They have an enterprise one, which is sold by the company called as Explosion. So they offer enterprise support also. This is the name of the company. You can see on my screen, explosion.ai.
And you prefer SPACY or the other one like Bright? You said some other.
But we are working on BERT. We didn't work on SPACY.
BIRTH.
BRT. Here I can type it out. So the BERT is maintained by a website called as Hugging Face. Okay, so this is BERT. Okay, bidirectional encoder representations, and this anything in NLP you want to go, you should check out this website huggingface.com. They are the open source community for NLP type of projects. You see here on my screen, Hugging Face.
Yeah.
Okay, so you want anything around NLP. So there are so many. There is from Google AI, Grammarly. All these companies actually support Hugging Face. So Hugging Face is the community, just like Linux community or like Apache community. In the same way, you have Hugging Face maintaining the latest repositories of natural language processing. So you can see here there is BERT. This is Distill BERT. Then there is Google's Tapas, Robota. Okay, these are all the latest that is there in the world of NLP. Now, each one of them, by the time you get expertise on some model, a new model will come. But for us, we did not want to keep changing on the models because you end up not working on any model. So fine, we have settled down with BERT now. So I'll move on to the example which we are trying to do. Sarvan and Satish, Jaydeep. What we are trying to do is, shall I move, Jaydeep?
Yeah, absolutely.
Yeah, so we are trying to build a real-time analytics pipeline using Apache Spark, where we are deploying a model on Spark. Okay, that is what we are trying to do. So we want to predict the delay in arrival or departure of a flight. So the first step, what we'll do here is, we'll open up the console. So here, our first step is, give all the parameter settings. So we are adding the value of the project ID. So if I do echo dollar project ID, I will get the value of the now why we are adding these parameters, because if we have to work on Google Cloud, we need information about the project ID. So here dollar. Okay, so this is the project ID that we have. So we are also storing that same project ID into a bucket. Okay, bucket is where we are going to store our data, and this is the region where we are going to store it. So now if I do a clear and if I do PySpark, okay, we will see PySpark should run. Why isn't it running? So let me just go into the compute. So here we already have a pre-installed Apache Spark instance that is running. Setting up Apache Spark will take a long time. So we have a pre-installed Apache Spark which we are using, and we will connect into this Apache Spark. So here if I type PySpark, PySpark will run for me, and I'll just do a Control C, to stop it. Control C. Quit. We will run our commands here also. And now we will run PySpark. So what we did is we just set the settings of our project, the bucket name, all of this information. So if you go here, type echo dollar project ID. Okay, and here also if you type echo dollar bucket, everywhere it is storing the same project ID so that we can use it in multiple scripts that we are going to write. So we will type now PySpark. Okay, so this is going to run. Sarvanan, you had a question, right? Which all environments we can run PySpark. So you can see here, we are running it from a VM machine. Okay. And in this VM, we will set up PySpark. And the next thing which we want to do is we want to we will set up PySpark within this. So Let me just, so what we are doing, we are setting up PySpark logistic regression, and we are using the mlib label point. So here what we are doing in the next command is we are creating a bucket that the bucket URL is given, and within this bucket we have the training data. So that is what we are doing. So we can view the training data in the solution here. So if I go here, in this, the training data is kept in the storage. So this is where we have the training data. You can see here there is flights, and within these flights we have the training.csv. So if I click this, we can see the training data. So this is the flight date, and we have the training data set. Now we will view our, let me, so within Spark, we will view our files. So what we are doing is we want to create a temporary view of our training days. So we created a temporary view, and now we will run our queries on this view. Okay, so what we can get is we are running some queries on this view that was created. Getting an error here. Schema. Okay, now it has run. We are reading. So what we have done in so far is what we did is first we created a we ran SQL queries on the Spark, and then we are creating a schema in Spark, a real-time data set, a view we are creating in schema so that it can be queried in real time. And now what we are going to do is we are going to read that data which is created in Spark into Spark QL. So here we are creating the data into Spark QL, and then we will now query that data of Spark. Inspect that data which is there in Spark. Okay. We can also, like in Jupyter Notebook, we can also view this data, do a train data.describe. So it will show us information about this data.
So Spark is reading those JSON and creating a in-memory sort of table out of it.
Correct. So it is real-time analytics. So all the processing is going to happen in memory. So all of this which we loaded into that, it is there in the memory of Spark. That is why the processing can happen while it is through the data pipe.
So as new files gets added to that bucket, it will keep adding to the table.
Yes.
Must be slow compared to a regular table, isn't it?
So see, it will be, since it is going to work in memory, so you can actually create a cluster of Spark. That is the advantage. Like any in-memory database that you use, the only way you can scale it up is through vertical scaling, which means if your machine is 4 GB, you will have to buy a new machine of 16 GB and vertically scale and improve the performance. So from 4 GB, you go to 16 GB, 16 GB, you go to 32 GB, and from 32, you go to 64 GB, correct? That is how you will buy higher power machines so that your in-memory database will work better. Now, the advantage, now the problem with vertical scaling is it is very expensive for a company. That means if it is a startup or even if it is a bank, if I have to go and buy a 64 GB machine in the market, it will become very expensive for me. But I can always go and buy 4 16 GB machines from the market. Okay. If one 64 GB RAM machine is going to cost me maybe 4 lakhs. Okay. If I want, I can go and buy 4 16 GB machines for 2 lakhs. The cost of smaller RAM machines are always lesser compared to the cost of higher RAM machines. So the advantage you get with Spark is instead of buying one machine of 64 GB, I can take 4 machines of 4 GB and create the cluster. And now on this 4 machines of 16 GB RAM, on this I can run 4 Spark clusters, which will give me the power of 64 GB machine. Make sense?
Yeah.
So that is the advantage you get when you use Apache Spark. It is savings of cost in infrastructure and horizontal scaling.
Okay, understood. Does it allow indexing?
So because it is in memory, you really don't need to index it. It is all of that, it is taking care internally.
Okay.
So unlike a regular database where you're doing indexing and all of that, here, whether it is NoSQL database or real-time databases, most of the time, the approach that they have is not index-based. They rather have partition-based. So if you store anything in a NoSQL database, it is in Oracle, Microsoft SQL, or other RDB-based databases, you are indexing it. Whereas in NoSQL databases, the approach for indexing is using partitions. You use data partitions, which works like an index. So here you can see we are now running the query on Apache Spark. And what we have here is it is giving us the summary information about the data. Now the next step for us is to build a logistic regression model. Our data is loaded into Spark. So we will create a logistic regression model. So you can see here, we had already imported label point. Now we are creating a function where we are passing the raw data, and it will return the labels, and the raw data is containing departure, taxi, distance, all this information. Now this particular function to example, we are mapping it with our raw data. So that it runs on the raw data. That is what we are doing here. And then we are going to use logistic regression to train our raw data, which is examples. So this is the logistic regression package within Spark, which we are training the examples data. Now, after the training is done, we will view the model, okay, the equation of the model. So we are looking at the logistic regression weights and the what is the logistic regression intercept. Now, suppose we want to do the prediction. So what we are doing is, within this logistic regression, we are passing the values. So what we have is 6.0 is departure delay, taxiing out time is given, arrival delay is information is being the distance is being given, and what it will have to tell us is that whether there will be a delay or not. So what it says is that because the value is 1, uh, 1 stands for on time and 0 stands for delay. We are clearing the logistic model thresholds. Okay, we are not keeping any threshold. So you can see after the threshold is cleared, it is when you pass these value, there is 0.95% that it will be on time, and Otherwise, it will be when we are passing 36.2.584. Okay, this is the time. Then there is 1.0% that there is a delay. So if we set the threshold value to 0.7, for example, instead of 0.5. So here, when the departure is at when the departure delay is 6.0 and taxing out time is 12, then there is no delay in the flight. The flight will catch up along the route. But if the departure is by the delay is 36 minutes, then surely there is going to be a delay in the flight. That is what it is predicting. What we'll do is we will save this model into Google Cloud storage.
Is threshold the cutoff? Like it's like above 70% it is positive and below 70% is negative.
Correct. Because see, here we clear the threshold and we increase the threshold to 0.75%, 0.70%. Now the model that got created using Spark, we are actually storing it in the bucket. So if I press enter, the Spark model is being stored in the bucket. So if we go into this, you can see it will show us the model that got stored. So this is where the model should get stored. Flights. It gave us an error. Let us just see why it is not storing. So here what it is saying, GS bucket flight Sparks ML output. Okay, so it has to be stored in Spark ML output model. So we will just go there. So there is no folder by the name Spark ML model. Let us just refresh and check. We are just refreshing it. Is it taking such a long time to refresh? So in this flights folder, there should be a model folder, and in that Spark ML model, it should store the file. Now here, okay, we will just go ahead and try saving this file. So even though file is not there, it is taking the part of the model file and it is saving it here. So if we go back now and check on the Spark here, if I refresh this, so here we have saved the Spark ML model output. So if I log in, the model output is saved in this folder. Okay, so this is the file and the model that got saved. So we will just remove all the files that were assigned to the model, make it 0, and then now let's print the model. Now we will retrieve the model from the storage location. Okay, so we have retrieved the model from the storage location. And now we are again passing the parameters. Now this time the model is persisted. So even if we switch off the Spark, you still have the model saved on a storage location. So that is why when we are passing this, it is still giving us the values. So another one, if you do this, so this is the Apache Spark implementation using Google Cloud. I hope this helps, Sarvanan. This is something which you had asked for earlier, remember? But we did it directly on the Spark cluster.
Yes, sir.
Okay. So what you are doing is you are using PySpark in Jupyter. You create the model, and that model will be, if you see here on my screen, the approach what you did is correct. Actually, you have to build it in your local environment. You don't directly go and build it on PySpark. That is not a, but this is only for demo purpose that I'm showing. So your model that is there is stored in the metadata folder. So this is the model file that you have, and this model file is what you will again access the next time. So if you see here on our screen, once you create your model file in your Jupyter notebook, you can access that model file. You can see here, this is the loading of the model file that is happening. And once you load, so you can deploy this package using an Android application, or you can also deploy it using a web application. So Python based web application. I showed you last time that example of Flask, right, where you loaded a Python, where we loaded a application in Flask, and then we were deploying. Same way, your data that is coming in real time. So it could be a real-time data that is coming from Apache Kafka or from a mobile or an IoT. It will process it, and then you will display it on your mobile app or on a Flask. So that is the approach that you will take when you're building the data pipe. Any questions? I hope this was helpful. In brief, I'm showing you the concepts that are used. Any questions? Sarvanan, Jaydeep?
No, none from my side.
I hope this is all meaningful and you all will be able to use in your workplace, right?
Yeah.
Yes, sir.
You will get ideas. It is a lot of detailing is required. I wouldn't say that we will all become experts in day one, but you all know now the path you can take. I wouldn't say one person will be able to do. It will be a team effort. Multiple people will be working together to do the implementations. So I'll be sharing these files, okay? The deployment files. You can go through the code. All the labs that we did, I will upload it. I have to just, clean it up little bit. So by tomorrow or day after, I'll put up that files and, send an email to Monica. So you'll all find that files over there. So some of the screenshots also I'll put so that, it becomes clearer for all of you how to do the implementation.
Yes, sir. Screenshots would be helpful. Yeah.
I'll put with screenshots. So in the next 4 sessions we have, next 2 weeks, right from the beginning till date, if you have any questions, anything, let me know. Any use cases you have in your office which you want to discuss or you want to implement, we can do that in the next 4 sessions that are coming. And I'll keep showing you more such examples, that goes beyond data science, primarily with regards to deployment, how they are used, how do you build data pipes, all of that we can do it. Implementation pieces I will show you. Okay. Any other thing, Jaideep, Sarvanan or Satish, you need from me?
No, all good.
Okay.
Same here, sir.
No, sir. Good.
Tell me, Sarvanan.
No, sir. I'm good.
Okay. If there are no questions, then we will end today's meeting.
Maybe a sample code of doing the same text detection using bot.
Sample code. Actually, there are about 300 files, Jaideep, for that, and then little bit is proprietary also. But I will give you examples from other websites. That is okay. On BERT.
Yeah.
I'll give you some sample codes of BERT implemented on other sites that I will share with you.
Great. Thank you.
Yeah. Okay. I think we will end today's meeting and we will meet next week. Thank you, everyone. Bye.
Thank you. Good night.
Thank you. Thanks, everyone.